7 there? Anybody admit to it? Having square root of 7 instead of square root of 11? Something you'll admit to. All right, you see what you did wrong? Okay, what? No? Oh, come on, Matthew. All right, so 57, what do you get? What does it factor into when we get the roots? Oh, there you go. 1, that gives us an x minus 1. And then what's the trinomial after that?
X squared plus 6x minus 2.
All right, do we agree? I need somebody else to make sure we're good. All right, now what do you got to do in this? Once you get to this point, that doesn't factor, right? But we can't stop, so you got to do what? Use which formula? All right, quadratic. And you just made a careless mistake on there. So when you're plugging in the quadratic formula, negative b is negative 6 plus or minus. B squared is 36 minus 4 times a, which is 1, times c, which is negative 2, over 2 times 1, which is 2. What happens here? Negative 4 times 1 times a negative 2 becomes positive 8. So it becomes 36 plus 8, which is 44. I think you guys did 36 minus 8. And you got 28. So this should be x equals negative 6 plus or minus square root of 44 over 2, which is negative 6 plus or minus 2 square root of 11 over 2. And then when everything cancels, that's where we get the negative 3 plus or minus square root of 11. Okay, on that. Let's see. For the most part, it looked good. Factored formula. Just make sure we're good here. 457. Okay, let's just continue with that. Oh, there you are. All right. I got the notes from yesterday. Do you need them?
No.
You got them? All right. And all right, that's it for now. If you have a root of 1, that's x minus 1. What happens with these two? How do I write them in factored form? Matthew?
It's x minus the quantity of negative 3 plus square root of 11.
All right, good. Negative 3 plus, whoops. Negative, hold on here. All right, you always subtract the root, whatever the root is. If the root is negative 2, you subtract it to get positive 2. If the root is 1, you subtract it. If it's negative 3 plus square root of 11, you subtract it. Then we got to subtract the other one, which would be x minus negative 3 minus square root of 11. That'll come up later. Okay, that'll come up later. All right, other questions? All right. I need to do one thing here, just because if you notice, there's no fractions in our answers. Okay, so that kind of presents us a little bit of an issue I just need to address so we don't make the same mistake. So we're going to take a look at one that does have a fraction in it. We're still finding all the real zeros. We talked about real numbers yesterday. They can include integers. They include rational numbers, which include fractions, and then irrational numbers, what do irrational numbers include? How are they different, Justin? Square roots. So they can have square roots as well. All right, so we're going to use the rational zeros theorems. We'll get into the positive and negative zeros tomorrow, and then the balance tomorrow. But we want to get through that part. All right, copy that down. We're just doing the one problem, so there's no guided notes. So just in your notebooks. It's fine. And we want to list the possible zeros. Don't get ahead of me because I want you to see specifically what happens. All right, so now this is the first time we've done a problem where there's been a constant in front of the leading term, right? So this is our A's, and our A's are the factors of 2, which is just plus or minus 1, plus or minus 2. Our B's are the factors of 6. So 1, 2, 3, 6. All right, what do I do for the possible rational zeros? Okay, how do I combine those from yesterday?
B divided by A.
B divided by A. So our possible zeros are B divided by A. So here's what I'm going to do with this. I'm going to put all the B's on top first. I don't need those braces. I'm just going to list them. 1, and I'm going to put the plus or minus with it for now. Now, A's are 1 and 2. Since I already have the plus or minus with the numerator, I don't need to put it down there as well. So technically, you're dividing each of those numbers by 1, and then you're dividing each of those numbers by 2. Well, what happens when you divide them by 1? You get the same thing. So you get all those whole numbers. So I'm going to list those. So I got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Got those. All right, now divide each of them by 2. Well, 1 divided by 2 is just a half. So I get plus or minus a half. What's 2 divided by 2? That's just what? We already have that. Don't list it again. Don't like double up. 3 divided by 2, 3 halves. Do I have that one? Nope. And then what's 6 divided by 2? 3. Do I have that? All right. So now I've taken my possible zeros from like just randomly picking infinite numbers, right? So how many do we have to pick from? 12. We got 12 to pick from. Well, you should know, since this is 2x cubed, if I have 3 roots, let me do something here. Can it look like this in factored form? X, X, X. No, because that's going to give me x cubed. Which one of those x's have to be? It's got to be a 2, right? So one of them is going to have to be a 2 in order to get that first term, that leading term, to be 2x cubed. Well, what does that lead you to believe one of our roots is going to have to be? It's going to have to be a fraction, okay? So you got to look at that like ahead of time as you're looking at an equation. Like, okay, I think I'm going to get some fractions. That'll save you time. All right, go ahead and use synthetic division with 1/2. Oh, while you're doing that, I'm going to try and pull something up real quick. All right, it should work out. So it should give you a remainder of what? 0. If it doesn't give you a remainder of 0, double check what you did there. Come on. All right, that's what I wanted. Okay. Did it give you a 0?
Mm-hmm.
So now here what we got. We got so synthetic division. 1/2 is here. I got 2, 1, negative 13, 6. 2, 1, negative 13, 6. 0, always start with 0. Add 2 times a half. 1, 2, 2 times a half is 1. Negative 12 times a half is negative 6. 0. All right, what does it look like in factor form at this point?
2x minus 1.
All right, 2x minus 1. Now here's where we gotta watch. It will get to that point. It has to get to that point, but you can't do it just yet. Because let me see if I can explain this and see if this will make sense. Don't write this down. If you make this 2x minus 1, your first instinct is going to make this 2x squared plus 2x minus 12. That technically won't work because in the end, 2x times 2x squared gives me 4x to the third. And what's my original function have? Just has 2x cubed, right? Here's how you got to do this. This is why I wanted to specifically talk about a half. Start with whatever this is, it's always x minus that number. start with x minus a half, times, we always multiply it by this reduced polynomial, right? Which would be 2x squared plus 2x minus 12. Well, what do you notice about the 2x squared plus 2x minus 12?
And factor out a positive 2.
Factor out a positive 2. So take that out. And I'm going to put it all the way in front. I'm going to put it all the way in front. And when I factor that out, that becomes x squared plus x minus 6. Here's where I get the 2x minus 1. Distribute your 2 into that x minus 1 half. You cannot give me a final answer with like that 1 half in it. So it's got to become a whole number or an integer. So multiply that by 2. That's where the 2x minus 1 comes from. Now, what happens to that? Factor it. That one factors into what? X plus 3, x minus 2. So what are my zeros? This is my factored form. Okay, this is my factored form, and my zeros are 1 half, negative 3, positive 2. So now you were right, and this is what I was trying. Like, according to our theorem, like if 5/3 is a 0, 3x minus 5 will be the root, but you have to start with x minus 5/3 first, and then in the course of the problem, you'll factor out a constant. So just be careful with that. So I wanted to hit that together to make sure everybody saw that. All right, I'm going to break you up into pairs because we didn't do any to do some little bit harder ones. And you know, if you pick the wrong numbers, it could take forever. So working together will help you so you're not sitting there working forever. So I'm going to break you up into pairs, and we're going to go through this, or you're going to go through this. Let me put you into pairs first. All right, let's go here with Tony and Mackenzie. Let's go Andrew and Hayden, Anna and Jordan, Justin and Aiden. Let's go Brooke and Holly. Let's go Katie and Logan. Let's go Matthew and Brandon. And Lizzie, Dakota and Carter. All right. So wait. We good there? All right, go ahead and go with the part. Yeah, there's something wrong on here. From the wrong. Yeah, no, look. Jordan, who are you with? Anna. Lizzie, you gotta go with Dakota and Carter. We got one group of 3. Fine.
Yeah. Casey had me bring a bunch of water for her mentoring class, and then she only took 2 days, and I was like, okay.
Hey, you're gonna need a piece of paper. You're not gonna be able to fit everything on here. Well, actually, you probably shouldn't fit anything on here.
Challenge.
Yeah.
I'm really good at picking the wrong numbers. I've been sitting here forever trying to do math.
I'll talk about that. Kind of, maybe, sort of. Did you get one? And all right, hey, listen here. Kind of through the directions. These are, I don't know. You may like whip through them, or you may just get stuck and just keep picking the wrong numbers. I don't know. Everybody's a little bit different. The answers are either over here in this glass door, or in the back of that glass door. So when you get done with one of them, go check your answer. If you're right, you move to the next one. So if you read the directions there, it says find all the zeros of the first polynomial function and write the polynomial in factored form. So do both. If you get the first problem correct, move to the second row of problems. If you miss it or you need help, you get stuck, then you gotta do the second one, okay? Same thing with the second row, find all the zeros, write it in factored form. You get it right, you move to the third one. Ideally, I hope you get down to 4 or 5. I don't know if you'll get all the way further than that. And I'll tell you at the end of the period where you need to go. Here's the deal, you guys need to make sure you work together. If not, you're gonna be killing yourselves. Okay, what I mean by working together, you're trying different numbers, okay, and to sharing the workload. Otherwise, you'll probably get stuck and not get too far. Questions? All right, go ahead.
I was confused on how we move this over to Friday. Is it when this should be left.
Tony.
The one I just did you know that one of zeros is going to be a fraction? Is that how we do it? So like right here, is
Hey, like I said, as you get one done, get all of it, check your answer, and then number 1, A and B are both on the same thing. Just lift it up and you'll see the answer.
so it's either 1 over 3 over 3. 2 over 3. So you can do it if you're other two. Just left it up there.
I'm just writing it.
All right.
So we have our options